Hello, my name is Dmitry and welcome to the Deplabs channel. I've finally gotten around to composite material technology. Today, I'll tell you how and what we're doing. We found an excellent specialist in composite materials. In just a month and a half, we've already achieved quite a lot. Here's where we decided to start. Since I ride mountain snowmobiles, this is something close to me. And we decided, so to speak, as a proof of concept to see how to work with composite materials in general, to make some parts for snowmobiles out of carbon fiber. This isn't something we came up with. This practice has existed for a long time. Many companies, especially in the States, are involved in this. Since low weight is very important for snowmobiles, especially at the front, because every kilogram there makes a difference. So, what did we decide to make first? That would be the control arms and the rear wheels, which are both important components of the suspension system. In other words, our goal is to make the 10-inch ones just a little bit bigger. Here's how we're going to do it. We'll use the process of carefully laying up a mold with vacuum infusion, which helps us achieve precise and high-quality results. The control arms will be made from a pre-impregnated composite fiber material, and then we'll cure everything in an oven to ensure maximum strength and durability, and finally see what we get. So, we have bidirectional carbon fiber, a high-performance material produced in Russia. We machined the mold on a Haas. We lay out the layers with the fibers oriented in specific directions. We temporarily fix them in place with spray adhesive. After that, the entire vacuum system is put on. There's a sacrificial fabric layer, and then the whole thing gets impregnated through infusion. After that, we get a blank like this. Like this. So we end up with a blank like this. Two blanks are glued together, then in this vacuum jig, air is drawn in to hold it in place, and the edge is machined on the lathe. As a result, you get this kind of quality, with no post-processing at all. There's a refrigerator for storing prepregs, otherwise they go bad. Basically, we bought a lot of resin, we have an oven, and so on. This is how everything is glued together with spray, nice and easy. The great thing about working with molds is that the repeatability is quite good, so everything can be carefully fine-tuned, and then you can put a highly skilled specialist on it. But you could also, alternatively, use a humanoid robot, specifically a biological one. It will absorb some of it.
Here are the parts that we need to look at. Please separate the distribution mesh, which is the section we are currently focusing on and working with right now.
So it's basically also some kind of technical fabric.
It's polyamide.
It doesn't get wet, right?
It does get wet, but it doesn't stick. It has almost zero adhesion. This is the mesh that distributes the resin. Wow, it's almost completely sealed off. So the flow of resin along the plane is actually quite limited in distance, and in fact it does not extend very far at all. But with the mesh, it spreads out and then just soaks through the thickness. But
I think so. Yes, and here we have it at the bottom as well. It's just not set up right now, but we can definitely show you the side as well if you'd like. I think it will cut through and pop off at this melting temperature. It just evaporates.
so you end up with a flat surface. Look at that. What exactly
That's good.
for us when gluing, but during processing,
But here, the adhesion will be amazing. Ah, is that because of the greasy fabric?
yes, it's because of the greasy fabric, basically right here on the mesh. The mesh splits like this because it has a special film. The film is perforated. You can mold it directly onto the carbon.
Yes, of course, that's against it. How much stronger do you think carbon is compared to fiberglass? Is it several times or tens of times stronger? Tens of times.
By order of magnitude.
Right? The tensile strength is much higher than steel, right? But people always forget one thing. It has a very high elongation coefficient. So basically, you shouldn't put it into concrete. Of course, it won't break, but the concrete, its energy absorption is worse. Well, of course, just these ones. And that's it. It will hold this tape in a vacuum. Is the tape special, or is it just regular window sealing tape? Or you can just put it in there together with it. And how much can the film hold?
180. There's a flange on the part here. There really shouldn't be any cavities at all, because any cavity, even a very small one, gets filled with resin, and that's basically a defect, since it's just resin without any reinforced fiber. It will eventually crack, so, well, it might just stand there, not a single one.
Yeah, right.
But otherwise, no.
Because in terms of strength, it's really rigid overall.
Well, you know, that is
But it's just that you really shouldn't, you know, actually jump on it. If you say put the skin right on the edge here, well, that's what causes it.
On the edge, yeah. Right now, at this very moment, absolutely right now,
Let's stick it on for G4 and also for G5. Those are for the platforms and the overall look and feel of the grip. Right now, this particular one is for G4. We still need to make another one for G5, which will be used for the test season. We'll take you along for the risky one, and you'll see for yourself right there on the spot. I really like the repeatability on the matrices. That's definitely good. And you won't have to glue it all the time. There are specially trained people who handle that. You can even step on it, and it cracked on.
all right, so, well, that is it.
Let's try this. It's so thin. Oh my God. Well, there goes the price, you know, just like that. Damn it. That surprised me. That's about the guy leading. All right, so it's easier to have an extra bag.
To be sure that actually this is the most, here we have the resin inlet and here is the outlet. So everything gets saturated, we close the inlet, close the outlet, and our first bag isn't connected to the vacuum at all.
Yeah.
The second package is always connected to a vacuum, which means that the first one will be a vacuum with its entire perimeter.
Yeah.
And thus,
There will be something here already.
not for, SOS is practically excluded, that is, you need to go with both packages. But it's like, if you take it with a slit, well, yeah, you'll ruin it. But you can ruin anything, my friend, if you really want to. I
Can make you a pre-vacuum with a water ring pump. I don't know if you need it or not. Are those pumps expensive? Why did we get them? These ones? Yes.
What's up? To check. I'll grab a bucket, let's mix the resin. Ah,
So, what kind of resin are we using?
we're using high quality epoxy resin, which is manufactured in Russia. It's truly excellent, very affordable, and absolutely awesome. And
This is kind of an option for an aluminum wheel. We just bought it to check it out for this purpose. For the snowmobile, there are ones like this. Ours will be the same, but made of carbon.
all right, let me get 200 grams for you. Just a moment, please.
Of component A.
Well, perfect.
Is that really all you need for one wheel? No way. That's so little epoxy?
It's vacuum infusion. It allows you to properly, completely, and thoroughly saturate the fabric so that there's a minimal amount of resin and a maximum amount of the actual reinforcing fiber material, in this case carbon fiber. You could use a roller to saturate it, actually. And there's an empirical rule that says you need about as much resin by weight as fabric. But with infusion, you need 3 times less. All right, as you can see, the magic stick digger. That's
Just how it is, no other way. Why aren't you bringing me the Kimscher screwdriver? Don't need it?
You have a feeling. Well, actually, it's because we haven't yet reached automated mixing. If the volume were at least approximately a liter, there's a storage tank over there that operates under vacuum. It has a pneumatic mixer and it mixes by itself. Right now, we have to very carefully mix and thoroughly degas such a very small volume of material as a separate step. And
Here it's vacuum right away. By the way, I actually have a spare one like this.
this is made from a paint pressure tank. Basically,
Ah, I see. So you actually started it up and basically sucked it out of there already, right?
now it's just flying for us. A special container where we will do degassing next, meaning if we don't degas the binder and start impregnating here, we have a deep vacuum and it will start to degas right inside the part, and there will be pores almost 100% for sure. Here, very little.
It boiled over.
It foamed up very quickly.
So we now begin the vacuum infusion process. For this particular wheel of ours, 150 grams of resin is sufficient. Everything has been thoroughly degassed, so now we'll open the clamp and the resin will begin to impregnate our workpiece. Here we go. It started. And what is the maximum distance that the resin can actually travel, for example, if you're infusing a really long part?
Through fabric, the distance is about 100 to 120 to 150 millimeters. Through mesh, the maximum distance depends on the resin and its viscosity. But you can estimate it as anywhere from half a meter to a meter. If you need more, a spiral polyamide tube is laid on the mesh. With that, the distance can reach up to 10 meters. If you need more than 10 meters, you have to add additional resin feed points. For example, wind turbine blades, composite ones, are infused all at once, and a resin feed point is placed every 10 meters because the carbon turns black and the sacrificial fabric gets saturated. That's actually why you can visually monitor how much has been impregnated and how much hasn't. Yeah, right now you can see it's moving pretty quickly along the mesh. It will reach the end of the mesh and then very quickly start soaking into the edges because right now most of the resin is going into the mesh since the mesh is the largest volume here. Look, there are infusion resins and there are non-infusion resins. Infusion resins generally have a long pot life and are usually low viscosity. Yes, this is related to the fact that some of their characteristics are lower than those of, well, of course you have to get rid of or remove agents that increase viscosity so that everything gets impregnated properly and thoroughly, but usually as a result, fracture toughness suffers. To improve fracture toughness, thermoplastics are added. They're quite viscous, and they significantly increase the viscosity of the mixture. Actually, one of the advantages of pre-preg is that you're not tied to viscosity there.
But you are tied to grandma.
All of this can be covered up. She just carefully closed the outlet, making sure it was completely shut, and then let it flow in there for a little bit.
So the outlet is closed, the resin has flowed in, and what's left here is just right. The inlet is clamped securely. We take all of this, meaning the entire assembly, and put it into our oven, which is preheated to 80 degrees Celsius for how many hours? 3 hours, and then it's done. So at the end of this process, you get a wheel that looks like this. Oh, this is without any post-processing or additional finishing steps. You could also coat it with a protective layer of varnish if you want, but as it is, it's glued together from two separate halves. Here, the rim is carefully trimmed so it doesn't damage the track, and the epoxy itself is formulated to be softer, let's say. The bearing is pressed in, everything is good, and we'll be testing it soon. And here is one of the levers. This is what the lever looks like after the process. I don't have the old one to compare side by side, but it's much lighter in weight. It's about half as light. We broke one on a tensile testing machine, 1.5 tons. It held up to about here, and then the aluminum eyelet broke. And this one I made from pre-preg. The first time we did it wrong. We arranged the fibers incorrectly, so the strength was only enough for 500 kilograms, and that was it. The orientation of the fibers is very important. We're making everything for the season, we'll test it all, put it through trials, and then go into production, because there are a lot of people who ride mountain bikes. Of course, it might seem childish, but reducing the weight at the front by 1, 2, or even 3 kilograms really makes a difference. In the future, our goal is to make everything possible in the suspension out of carbon.
There's a well-known story in certain circles. Some guys were making a part using a mold, and it had flanges. When you're making a part using vacuum infusion, it's really important to make sure there are no fabric tensions, because otherwise you'll end up with just resin there and no fibers. If you lay a layer at a right angle, you get fabric tension, and it's almost impossible to get rid of it because the fiber doesn't stretch. But these guys figured out how to avoid that, because when the quality control guy comes in and sees the tension, you have to redo the whole layer. So they trimmed the fabric at the corners, because then in the corners the fibers spread out and there's no tension. So they made a part, I don't remember exactly, but it was quite large. And the part is removed by the flanges. Wedges are driven in under the flange and the part is taken out. Then on the tooling for machining, they trimmed the contour and make some technological holes. So they carefully drove in the wedges, and as a result, the entire flange popped out. But interestingly, the whole part stayed inside because they had meticulously trimmed each individual layer. But they still couldn't pry it out, so they threw it away together with the tooling, and the tooling costs almost 10 times more than the part itself.
I hope you enjoyed it. Subscribe to the channel, share, and leave a like. See you soon.